In June 2025, an alert from the Atlas telescope flagged a blazing dot streaking through our solar system at nearly 152,000 nph, faster than any known asteroid, unmistakably interstellar in the span of just 4 nights. NASA confirmed the signal. This was 3I Atlas, only the third object ever witnessed from beyond the sun. But what followed broke every pattern. Its brightness was too high for its size. Its path, traced back toward the inner galaxy, showed ghostly deviations no comet could explain. Some scientists now argue it's more than just rock and ice. A possible test, a warning, maybe even a message. So what final signal did 3I Atlas really send? And why is the world on edge right now? The Atlas night crew in Chile kept their eyes on the data stream, waiting for anything out of the ordinary. On June 25, 2025, the automated alert system flagged a faint, fast-moving point of light, one that didn't match any known asteroid or comet in the catalog. The timestamp read 0317 UTC. Within minutes, the system ranked it as a top priority candidate, triggering a cascade of follow-up checks. For the next 4 nights, every clear hour counted. Each pass of the telescope added a new position to the growing track. And by June 29th, the object's motion was unmistakable. It was slicing through the sky at a pace that made even the most seasoned observers pause. The window for discovery was razor-thin. Star fields near the galactic center nearly hid the trail, and only by combining Atlas's rapid response pipeline with archival images from the Zwicky Transient Facility did the team realize the object had been visible as early as June 14th. Still, the official detection window, June 25th to June 29th, was all that separated a historic find from a missed opportunity. Every hour, the object gained distance, its path pulling it away from the inner solar system. Slack channels and late-night calls buzzed as the Minor Planet Center received the first alert. NASA's confirmation arrived less than a day later for the Atlas night shift. The realization set in. They had just caught the third interstellar visitor ever seen. And the clock was already ticking. Orbital dynamicists at the Minor Planet Center began crunching the numbers as soon as the positional data landed in their inbox. The trajectory wasn't just unusual. It was mathematically impossible for any object bound to our sun. The path traced out by 3I Atlas forms an open hyperbolic curve with an eccentricity far above 1. In plain terms, it's moving too fast, over 152,000 km/h, for solar gravity to ever pull it back. This is what astronomers call hyperbolic excess velocity, a speed so great that even as the sun tries to tug it inward, the object simply shrugs off that pull and keeps going. The numbers point back toward the constellation Sagittarius, near the dense heart of the Milky Way. That direction isn't random. It hints at an origin somewhere deep in the inner galaxy, far beyond the scattered disk or even the Oort cloud. The object's inbound vector and velocity rule out any scenario where it could have been flung out from the solar system itself. No known planet or previously cataloged object could have given it this kind of boost. Astrometry teams ran repeated orbit solutions, each one confirming the same story. The object's speed and angle mean it's not just visiting. It's passing through, never to return. The last 2 interstellar objects, Oumuamua and Borisov, showed similar hyperbolic paths, but 3I Atlas stands out for its sheer velocity and the precision with which its orbit can be traced. Every new data point tightens the case. This is an interstellar traveler, a messenger from a place we can only imagine. Photometry teams at the Vera Rubin Observatory worked through the night measuring every photon pouring in from 3I Atlas. The numbers refused to add up. For an object with a nucleus just over 1 kilometer across, the brightness was off the charts. Even before the comet's closest approach to the sun, its coma stretched nearly 24 kilometers wide, a cloud of dust and gas that should have dimmed as it expanded. Instead, 3I Atlas shone with a crisp, almost metallic gleam. Albedo, the technical term for reflectivity, became the word of the hour. Most comets in our solar system reflect just a few % of the sunlight that hits them. This one bounced back far more. Enough to put it in the company of fresh ice fields or polished metal, not dusty rock. The Rubin data cross-checked with Atlas and Gemini South confirmed the outlier status. The surface appeared so bright that some photometrists wondered if they were seeing a hollow shell, or perhaps a crust layered with unfamiliar ices. Others pointed to the possibility of a highly porous structure, sunlight scattering off countless tiny surfaces. But no natural comet or asteroid in the archives matched this exact signature. The nucleus was too large for the level of brightness, the coma too uniform for a typical outgassing event. Each new frame deepened the puzzle. If the surface was truly this reflective, it would force a rethink of how interstellar objects weather the journey between stars. The only way forward was to push for higher resolution scrutiny, something only the James Webb Space Telescope could provide. The James Webb Space Telescope's observation window opened as 3I Atlas cleared the sun's glare, giving astronomers their first chance to probe its true nature. The Mid-Infrared Instrument, or MIRI, mapped the object's thermal emission across a full rotation. Instead of wild temperature swings or hotspots, signs of jets or vents, the data showed a stable, almost uniform glow. The heat pattern fit a body spinning with clockwork regularity, not a lopsided chunk of ice tumbling through space. Every 6 hours, the light curve repeated itself. Principal investigator Dr. Sato described the spin as uncannily steady for something this size. NIR spec. The James Webb Space Telescope's near-infrared spectrograph scanned for traces of volatile gases. The spectra revealed a coma dominated by carbon dioxide, but the signal was diffuse. No concentrated plumes, no sudden surges. The nucleus shone through with a crisp metal-bright reflection, echoing ground-based suspicions of an unusually smooth or possibly faceted surface. Yet, even with this brightness, there was no evidence of outgassing strong enough to nudge the orbit. Precision astrometry became the final check. Over 2 months, the James Webb Space Telescope and ground telescopes tracked 3I Atlas's position to within milliseconds. The result? Any non-gravitational acceleration, whether from jets, radiation pressure, or something more exotic, was smaller than 1/10,000,000th of a meter per second squared. In practical terms, the object moved as if gravity alone guided it. No measurable drift, no unexplained push. As Dr. Sato summarized, if there's an engine on board, it's quieter than anything we've ever seen. Avi's checklist for artificial origin reads like a forensic roadmap. Unexplained acceleration, extreme reflectivity, lack of outgassing, and a shape or spin that defies natural patterns. The consortium behind 3I Atlas mapped each observation onto this grid. No measurable non-gravitational acceleration. JWST and ground teams set the upper limit tighter than for any previous interstellar visitor. The reflectivity is high, but not without natural precedent. Outgassing is present, though muted. The spin remains regular, not erratic or suggestive of engineered control. Each criterion demands precision data, yet raw astrometry and spectra sometimes land behind short embargoes, fueling debate. Officially, most data releases follow standard review cycles, days, not months. But in a case this rare, every hour of delay draws scrutiny. The process designed for rigor can look like opacity when the world is watching. 3 interstellar visitors, 3 different stories. Oumuamua, the first, raced through with no tail and a shape that defied every known category. Thin, elongated, accelerating for reasons no one could prove. Borisov II arrived as a classic comet, venting gas and dust just as theory predicted, but moving faster and burning brighter than anything from our own backyard. Now 3I Atlas blurs the lines. It carries a broad coma like a comet, yet its nucleus shines with a brightness and symmetry that hint at something new. Astronomers call it a hybrid, neither comet nor asteroid, but a sign that the galaxy's inventory is broader than textbooks allow. Each encounter pushes the boundaries, raising the stakes for how we search and how we interpret. The next radar pass, scheduled for perihelion in late October, could reveal structure or movement missed so far. Until then, the world watches, waiting to see if this visitor will rewrite the rules once again. As of this broadcast, the object's true nature remains unresolved. What is clear is that each new interstellar visitor tests the limits of our detection and analysis. For now, 3I Atlas stands as both a scientific puzzle and a reminder that the search for answers relies on open data and global scrutiny. Okay,